Good morning, students. This is your maths teacher Santosh Kumar. Now we are going to see the concept of the chapter determinants, uh, and its application also. Okay. So what is meant by determinant? We are going to see now. First of all, we'll see the definition. Determinant is a number associated with each square matrix. It's just a number associated with each square matrix. Okay, determinants concept itself is based on the square matrix only. Okay, so every matrices will be associated with some number. That some number is nothing but determinant. Okay, so as per the definition, which is a determinant is a number associated with each square matrix. Okay, so the meaning of this one is every square matrix is mapped to one number. That number is nothing but determinant. Okay, so for first we are going to see what is the number associated to this square matrix. Okay, I mean what is the determinant. Okay, so A is the matrix A is given over here. How to find out the determinant of A? See this modular symbol, no? They call it as determinant. How you need to read this one is determinant of A. Okay, so determinant of A, if you want to find out, again I'm telling you, determinant is a number associated to each square matrix. This chapter is full based on square matrix only. Okay, so every square matrix will be mapped to a certain number. That certain number is nothing but determinant. Suppose if you want to find out the number which is associated to the matrix A, how you need to start is determinant. So determinant of A is equal to, how to find out the determinant is just a cross multiplication. Okay, first you write the given matrix in the determinant form: 1, 3 and minus 1, 4. See how you need to read this symbol is determinant of, right, 1, 3 and minus 1, 4. So how you need to find out the determinant value is, okay, just a cross multiplication. This way you have to cross multiplication 4 and then this way if you cross multiply, that is right hand multiplication into left hand multiplication. Okay, right hand multiplication is positive and the left hand multiplication is negative. Okay, so this way if you multiply, you need to put minus of, then product of these two. Minus 1 into 3 is minus 3. Okay, so when you multiply right hand side, it is positive. When you multiply from the left hand side, it is negative. So minus of you have to start. Okay, then these two numbers product, so which is a minus 1 into 3 is minus 3. So 4 minus of minus is plus, so it becomes 7. 4 plus 3 is 7. Okay, like this you need to find out the determinant for 2 cross 2 matrix. Okay, just a cross multiplication, 4 minus of these two multiplication. Okay, then for a 3 cross 3, how to multiply? For a 3 cross 3, you consider any one row. One row's element alone you consider. Any one row or any one column you can consider. Let me consider row 1. So if you consider row 1, the elements are 2, minus 1 and minus 2, correct? After each element you make one 2 cross 2 determinant. You make one 2 cross 2 determinant like this. Okay, and then now see this element is A11. This element is A12, correct? It is A12, right? A12, this 1 and 2 if you add, what will you get? You get 3. That means it is odd number. That means odd placed number. Okay, its position is odd. Like that you have to consider. Okay, so if the position is odd, then you need to change its sign. So minus 1 is in odd place. It is in odd place, so minus 1 you need to change its sign. It becomes plus 1. Again this element is, it is A13. correct? A13 is 1 and 3. If you add, you get only 4, so it's a positive only. It is a even number only. Okay, so you need not change any sign for odd position number alone. Position for odd positioned number alone, you need to change its sign. Okay, then so what we are doing, any one row you consider. I am considering the row 1 and writing its elements. Odd positioned number alone I am changing. Okay, changing its sign. So sign I am changing. That's a rule. Okay, now what you have to do, after each element you made one 2 cross 2 determinant you opened. The 2 cross 2 determinant, how you need to find out is, listen, this for this 2, the 2 present in this column and this row, leaving those elements. So leave this 2 present in this column and this row, right? So leaving those elements, what you will get is only these 4 elements. Those 4 elements alone you have to write it. So which is 2 minus 1 and minus 5 and 0. Okay, fine. Similarly, this 1 lies in this column and this row. Leaving those elements, you need to write the remaining elements, 0, minus 1 and 3 and 0. Similarly for minus 2, this element lies in this column and this row. So these 4 elements you have to write. So can you say 0, 2 and then 3 minus 5. Okay, so now find out the answer for this one. Okay, what is the answer for this one? 2 is as it is. Okay, for this you need to apply 2 cross 2 determinant. How you cross multiplied here likewise. So 0 into 2, 0 minus of these 2 multiplication is plus 5. Okay, plus 1 into 0 cross multiply 0 minus of minus 1 will become plus 1, minus 2 times this one again cross multiply 0, these 2 if you multiply, minus of 3 into 2 is 6. Okay, so the value for this one is minus 10, and this will become 1, and over here it becomes plus 12. Okay, so answer is minus 10 plus 12 is 2, 2 plus 1 is 3. So 3 is a number associated to this matrix, so we call this 3 as determinant. Okay, so I mean determinant of A, so this is actually determinant. Okay, correct. Similarly, same problem only I have written over here also, right? I told you can consider any one row or one column, any one row or one column I told you. Now I am going to find out the determinant value for this one. Okay, find out the determinant value for A by expanding the first column. Okay, first column elements are what here? 2 and then a 0 plus 0 and then another element is 3. Okay, so now after the element 2 you need to write 2 cross 2 determinant after each element. 3 means it is plus 3, right? So plus 3 and determinant. So now you see 2 lies in this column and this row, so it becomes 0. Remaining elements, 2 lies in this column and this row, so remaining elements are these 4, so which is 2 and minus 1, minus 5 and 0. Okay, and next 0 lies in, right, this row and this column. You see there is no odd position number over here because this is A11, so 1 and 1 if you add you will get 2. This is A21, this is 0. Anyway it's 0, no? So you have to change this sign, but 0 doesn't have any sign, so leave it. If it is plus 5, then you have to put minus 5 here. If it is minus 5, then you have to put plus 5. Okay, this is again it is A31. A31 means what? It is 3 plus 1 is 4 is an even number, so its position is even only, so you need not change its sign. Only for odd position you have to change the sign. Okay, so now 0 lies in this row and this column. Remaining elements are minus 1, minus 2 and then minus 5 and 0. Okay, so for 3 again, for 3 3 lies in this row and this column. So elements are -1, -2, and then -5 and 2 and -1. It lies 3 lies in this row and this column. So 4 elements are this one. Okay. So now if we expand, so 2 is as it is. 0 into 2 is 0 into 2 is 0, minus of these two multiplication is 5. These two multiplication is minus and minus is plus. Okay, and this is anyway 0, so its whole value is going to be 0, so leave it. And here if you see -1 into -1 is +1, minus of these two multiplication is -4. Already one minus is there, so +4. Okay, so this becomes -10 and 0. This is 5. 5 into 3 is 5 into 3 is 15. Oh wait, somewhere we made mistake. So which is -10, and once again everything is correct. Fine. So 3 lies in this row and this column. So 3 with this is a -1, we multiply it +1, and 2 into this is +4. Okay, so wait, this is +1 and -2 + 2, 4, correct, 15. And over here for 2 the lies in this column and this row, so which is 2 and -1 -0, so 0 and +5 you get 0 and +5, but yeah, it's correct. Then any mistake is done over here, 0, over here. See over here, this cross multiplication is 0, and this one multiplication is actually what? 0. Actually it is 0. This cross multiplication 0, and this minus of 3 into -1 is -3, so it becomes +3. So it is becoming 3. So you have to add, this will become 15 minus 10 is, what do you get? 15 minus 10 is 5. Okay, so here also again -10 and 15, so which is 5. So you look at the answer, both the answers are same, 5 and 5 over here, both are same. Therefore here we expanded but row 1, and here we expanded the column 1, right? By using column 1 we found over here, by using row 1 we found the same answer, so you get the same answer. Okay, so hope you all you are able to understand. Fine. Then the next topic is about singular matrix. Okay, so what is meant by singular matrices? A matrix A is said to be singular matrix if determinant of A is 0. Okay, matrix A is said to be singular matrix if determinant of A is 0. Then one question based on this one: find X if matrix A is singular. Okay, if its determinant value is 0, then the matrix A is said to be singular matrix. That's it. They are saying this is singular matrix. That means its determinant value will be 0. So you have to find the value of X. Okay, so determinant value is 0, they are saying. So determinant of A is 0. Okay, I mean this one. A is a determinant 6x 2 minus 1 2 minus 10 5 and 2. Okay, so now we'll expand the first row. Okay, so which is equal to 0, and shall I do here? So expanding the row 1. So row 1, if you expand, 6 lies in this column and this row. Shall we do directly? 6 lies in this column and this row. So remaining 4 elements are this one. So for that 4 elements you need to find the 2 cross 2 determinant. So cross multiply, -2 and minus of 5 into 2 is 10. Okay, and see plus x, no, but it is odd position. Its position is odd. So minus x lies in this row, this column and this row, this column and this row. So 2 into 2 becomes 4, and this into the minus of minus 10 into 2 is -20, so it becomes +20. Okay, and then for the last element plus 2, the last element present in this column and this row, this column and this row. Now cross multiply 10 minus of these two multiplication is plus 10. Okay, so which is equal to 0 as they have given. Now this is minus 12, so 6 into minus 12, and over here this is 24, so minus 24x. Okay, and then next this is 0, so which is equal to 0. So this gives minus 24, so minus 24, no, so minus 24x is equal to 6 into 12 is what, 60, 72, yeah, 72, so minus 72, so when it goes to that side plus 72. So what is the x value? X value will be, so minus 24, when you send it to that side, x is equal to 3, right? 3 times 24 is what? 72. So, but it is minus 3. So x is equal to minus 3 we got. Okay. You able to understand? It's easy only. Whenever they say singular matrix, indirectly they are saying determinant value is 0. Okay. Next, another note is if A is square matrix, if A is square matrix of order n, right, it's a note, then determinant of Ka will be equal to k power n into determinant of A, where k is a constant. It can be any constant. Okay, so determinant of Ka is nothing but k power n into determinant of A, where n is the order of the matrix, square matrix. Okay, for 3 cross 3, if A is a 3 cross 3 means n is 3. If A is 2 cross 2, then n is 2. Okay. So you can take an example. The determinant of A is this one, and you can verify this one. Determinant of 2A is nothing but 2 power 2 into determinant of A, right? What we have seen over here in this note. Okay, this note I am talking about. So A is equal to this matrix, and verify determinant of 2A is equal to 2 power, like a 2 power n into, this is like k, 2 is k, so determinant of Ka is equal to k power n, because it's a matrix is 2 cross 2 now. So this one. Okay, so we'll verify this one. So determinant of 2A, what is 2A? 2 times A is nothing but determinant 2A, right? So 2 times you do this, multiply this matrix by 2, so 2, 4, 2, 2. For this, if you find out the determinant value, it becomes 4 minus cross multiply minus 8, so it gives minus 4. Okay, and similarly this is LHS, left hand side, and RHS you find out. RHS is 2 square is 4, and determinant of A is 1, 2, 1, 1, so 4. Expand this one, cross multiply again, expand the determinant, 1 minus 2, 4 into minus 1 is minus 4, so minus 4. So LHS and RHS both are same. Okay, so what we can say is determinant of Ka is equal to k power n into determinant of A. It is acceptable. Okay, and next is this problem. Fine, how to find out this one? Two determinants are equal, then find the value of x. That's a question. So don't equate these two values. Okay, that's wrong. If you equate these two values, and if you are finding the x value, it is wrong, because it's not a matrix, it is determinant. So determinant is only a number. Okay, so you have to find out a number, and then only you have to equate. Okay, most of you will equate, and you will be getting x value as 1. That is wrong. Okay, so now determinant value you find out for this one, cross multiply 2, this one if you cross multiply, minus of this one if you multiply 20. Okay, multiply 2x square, multiply minus 24. Okay, so this becomes minus 18, 24 you send it this side, plus 24 equal to 2x square, and these two if you cancel you get 6 is equal to 2x square. So 2 when you send it to that side, 3 is equal to x square, so x value is plus or minus root 3. Okay, so but when you directly equate, okay, the x value will be 1, so it's wrong. Fine. So determinant means it's a single number. You need to find the single number and then only equate. Okay, it's not a matrix now. Then last one. This here we can see the proof alone. Examples you can take it and do. Okay, you can check. You can verify with some example. That is for any two square matrices A and B of same order. Okay, order should be same, and it should be a square matrix A and B. Determinant of AB will be equal to determinant of A into determinant of B. Both will be same only. This is another note. Okay, please note it. And this in some typical problems you have to do this application. So you have to know this. So determinant of AB is determinant of A into determinant of B. Okay, I think you are able to understand. Thank you. That's all about today's session. Thank you.